Hey YouTube, welcome back. Today we continue our series in serverless extensions, a serverless crash course, and we continue our course in talking about Lambda functions and Lambda functions in details. Today we will talk about the Lambda Extensions API. What is it? How it works? Why we need it? And we'll give you an example. So let's just start. The AWS Lambda Extensions API is a feature that allows you to extend the capabilities of your Lambda functions by integrating external tools and logic into the Lambda execution environment. These extensions can be used for various purposes like monitoring, observability, security, and governance. Let's talk about how it works. So let's talk about how it works. And we start first by the types of extensions. So the types of extensions, let me just make sure. The types of extensions we have external, no, not that. No, this is not right. This is not right. This is not right. We have external, like there's two types of extensions. We have external and internal extensions. The external extensions run as a separate process in the Lambda execution environment and can continue running after the function invocation is complete. The internal extension are part of the function's runtime process and are useful for use cases like custom metrics or logging. We want to talk about the life cycle. Let me try to copy this and put here. We want to talk about the life cycle events. I guess we doesn't need anything. We just need to see what is it. So the lifecycle events, extensions can use lifecycle events to execute logic in different phases of the Lambda execution, such as before the function invocation invoke and after the function invocation shutdown, for example. Also, we have the communication. Basically, extensions communicate with the Lambda service via HTTP API provided by the runtime API. This API allows extensions to register for lifecycle events and interact with the function invocation flow. Okay, that's okay. We have two types of invocations. It uses the lifecycle. They communicate with each other. Okay, they work like that. They are pretty simple to work. Okay, but why we need the extensions? So let me go from this section away and why do we need it? So I will say first that we could use it in enhanced monitoring and observability. So let me just copy that because it's a really long word to type. So extensions enable more advanced monitoring and observability for Lambda functions. They can collect and send custom metrics, logs, and traces to monitoring logs. Also, we can use it for improving security. So security tools can be integrated as extensions to monitor and enforce compliance policies. We can use it for the efficiency. So extensions can automate tasks related to governance, auditing, and management, improving efficiency. We can use it in custom workflows, and I guess this is the most thing that we could use about. So basically, you can create custom workflows that are executed in response to Lambda lifecycle events. um, we could say, okay, we can talk about some example. So we want to create an extension. So we want to write a script like in a language that's been supported by Lambda. It will be mainly Node.js because we are in JavaScript file, as you can see. This script can log information about the Lambda invocation, such as start and end time or any other relevant data. The the extension. The package your extension code along with any dependencies. We'll talk about the packaging, deploying, and function execution. But today we only want to focus about creating such an extension. So first, it will be pure Node.js. So let's just create a file here. I call it extension.js. And I'll have this file here. I just require the HTTP. I will register for invoke and shut down events. So const register, it will equals I guess I don't need event and context with me. I will create the option object options. You could see what we can make a video about or the option objects. So we have the host name. Maybe you could say let's say localhost or sandbox. We will have the port 80, and we will have the path extension, I guess extension event, and we'll have the method post, no method not method, and host name not host name, and we have the headers. No, the headers not content type. The headers, it will be let me copy it because and long extension name, and I just give it this name. So I have a register for it. We created the option, and yep. So let's just start here and create a const rec. Let's say make a request, http.request, and let's say that I guess it doesn't need all of that. This is too much. We will console.log, status.code. We could say that also extension register, and we have the status.code. Yeah. No, why? Control Y. And we can make like request dot on. I could say, but no, this isn't in the function. This is in the register function. It's not just in the air here. So it will be request dot on. It will be error console.log the error. Let's make it like that. And I guess we have lastly to make request.end. Okay. Okay, so everything looks quite good here. So let's just call the register. And we could have, okay, so we can start an HTTP server to listen for the lifecycle event. So we create the extension here. Let's just create, let's start an HTTP server. So I would say, okay, HTTP dot create server. It will be request and response, and I guess that listen to, I guess we said 8,000, right? Or it I guess 880. Let me check. Yeah, 880. So we will just let data. It will be like an empty string. I'm just trying to make everything here, pure Node.js, so we'll not add any complication on it. And I will say, okay, rec on data, and we have, for example, the chunk and chunk plus equal data, and we have rec on end. And what I will do here, I'll say if rec dot rec dot URL equals I guess invoke. I guess it just need to be invoke, not all of that, right? I guess it's only need to be invoke, not all of this. Yeah, it need to be invoke. We will cancel log extension invoke with data or extension started. Let's say extension started, extension invocation started. No, we will say if it will equals invoke, we will say function invocation started if it equals, else if the rec URL equals shutdown, I'll say invocation ended, and I will say okay, everything looks good, everything looks fine, and I'll say okay here, rec dot write head 200 and res not res not rec res, and res dot end. And what's happening here in this example, the extension registers for the invoke and the shutdown events and logs messages when these events occur. The script needs to be adapted to the Lambda execution environment and should be deployed alongside your Lambda function. Here, as you can see, the Lambda, and this is a small example. You will find plenty of other examples. This is a really dummy one. It just to show you how we can do it. So in conclusion, Lambda Extensions API opens a lot of possibilities for customizing and enhancing Lambda functions behavior, making it a powerful feature for complex serverless applications. So that's it for today's video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you never miss a video, and see you in future problem.